Hello, ladies and gentlemen. Today we are going to take a look at graphing cube root functions. So not just square roots, but now what does it look like when you have a cube root? Remember, a cube root is the radical sign with a little 3 guy right there. We're talking about equations that have a cube root in them. Now, what makes a cube root different from a square root? Well, you can cube root negative numbers. With square roots, you couldn't. So for our notes today, you're going to take those again in your graphing notebook using graphs. We're going to have 3 of them. Calculator might be a necessity for you, but hopefully not. And again, those 2 different colors are recommended. So let's look at the general parent function for cube roots. So once again, we have a parent function that we could just visualize and see what's happening. So every time we place a value in here for x and take the cube root, if we generated a table of values, this is what that table of values would graph into. So we'd have a point 0, 0 because the cube root of 0 is 0. We'd have a point 1, 1 because the cube root of a positive 1 is 1. We'd also have a point negative 1, 1. Or negative 1, sorry, negative 1. Because if I take the cube root of negative 1, it's negative 1. So we have 3 values here that kind of make this sort of swoosh across the page. Notice there's more going on here than there was with the square root. It's sort of a wave here, if you will. This is the general shape of a cube root graph. So it does have that other piece that a square root graph did not. The domain and range now, when we describe those for a cube root graph, we're talking about the x values. Now notice because there wasn't a certain starting x value we were looking for, we have a whole bunch of graph on this side, we have a whole bunch of graph on this side, we have arrows on either end. So the domain is going to be from negative infinity until positive infinity. It goes on and on forever in both directions. The range will be exactly the same, okay? It's going to continue to grow here on the right-hand side, decrease on this side over here, getting lower and lower. So we're going to end up with a range of negative infinity to positive infinity. All right, so cube roots, a little bit easier with domain and range than square roots. So what about our shifting? Well, the same rules still apply. So just because we understand the whole idea of shifting, those same rules. So whether you write them again or not, doesn't matter to me. But numbers on the outside, guys, up or down. Numbers on the inside, left or right. Number in front, that's that amplitude, the thing that makes it stretch up or compress down. It's kind of like how we find that second dot we graph. And then the reflection in front, so we're going to flip it over. Remember how to do that. So this is what we're talking about when we talk about graphing any sort of root. The shape just changes now. So our first example here, remembering that we're graphing a cube root, so that's going to be this general shape right here. We want to first use that parent function. So the parent function again was 0, 0, 1, 1, negative 1, negative 1. And it kind of swooshes out this way. It doesn't make a line, swooshes up this way, makes sort of a wave. This is the parent. Okay, we know that it's not a straight line, even though those 3 dots go in a straight line because we're smart and we know that cube roots don't make straight lines, okay? So parent function has been graphed. And now we need to identify how it moved. So inside here, we're going to shift the points to the right 2 and then up 1. So we're going to take this parent function and move the 0, 0 dot here to the right 2, 1, 2, up 1. So here's the new 0, 0 location. Let me see if I can get another color here. There we go. Ink color. How about blue? There we go. So we're going to move to the right 2, 1, 2, up 1. This is the new 0, 0 spot. And then if I go ahead and graph from there, I would go up 1 over 1 to make sort of the top half, down 1 over 1 to make the bottom half. And I would draw in that same wavy shape, okay? There is my new cube root graph, okay? This is the g of x that we just graphed. That's how he moved. So we're identifying that shift. Now let's talk about domain and range. Well, you know what? The arrows are still on either end, right? So my domain is still going to go from negative infinity to positive infinity, and then my range, negative infinity to positive infinity. All right, or all real numbers. Graphing example number 2, ladies and gentlemen, let's go ahead and take a look at this one. So if I graph the parent function, when I graph him, I would start at 0, 0, I would put a dot at 1, 1, negative 1, 1, and draw that sort of swoosh. My connecting the dot skills are lacking. There we go. And now we need to graph that transformed function here, or we need to figure out how it has shifted. So I'm going to go back to my red here. This was the parent. Now let's graph our g of x. So here, we're going to shift everything. It looks like to the right, but it's actually to the left. Here we go. Because of the plus sign in there, we actually moved to the left 5. And there isn't anything up or down. Okay, so to the left 5, I'm going to take that 0 dot here and move to the left 5. 1, 2, 3, 4, 5. So that's the new middle part of my wave, if you will. Now, normally the wave would go up 1 over 1 like this, down 1 over 1 like this. You'd make those 3 dots. You'd draw the same sort of shape of that wave. But notice we have this negative sign right here. That means we need to flip that wave over. So instead of going up 1 over 1 here, we would go up 1 to the left 1 here. So we can flip that wave, and then we go down 1 over 1 there. And notice how the wave sort of has that hump in the different location, if you will. It just looks like it's flipped over compared to the other one. So that whole idea of now, again, I guess you could kind of remember it as, see how those 3 dots kind of slope downwards here? That idea of that negative helping do that. So we've shifted him, we've reflected him over the x-axis. Now let's talk about domain and range. We'd have negative infinity again to positive infinity. My positive infinity is kind of looking like 8 there. Negative infinity. Let's try this old school here. And then positive infinity. Okay, so there we go. We have our lovely shifted and reflected cube root graph. One more. Here's our third example, a little bit more going on. So again, we have this parent function happening. So I'm going to do 0, 0, 1, 1, negative 1, 1, just so we can get a general feel for that shape. One more time, a little bit of a wave here. This would be a smooth wave, not a straight line. There we go. Love it. All right, so now let's graph how this has shifted. Inside with the plus 5 is actually to the left 5. Here we have down 1. And right here is actually going to stretch or make taller, if you will, this wave. So if we were going to graph this one, we would start by moving that 0, 0 point. We would move him based on that shifting to the left first. So let's shift this 0, 0 point to the left 5. 1, 2, 3, 4, 5. Then down 1. There he is. So that's my new 0, 0 point. Now, in order to apply this sort of stretch, if you will, remember my dots used to go up 1 over 1, down 1 over 1 here, kind of make 3 in a row. Now I'm going to go up 2 over 1, applying that shift. Down 2 over 1, making them farther apart. Okay, so it basically stretches that wave and makes him taller, if you will, but he still has that same general shape. Okay, so my domain and range. Domain, I think you're catching on, negative infinity to positive infinity, and once again my range is the same thing. So domain and range for cube root graphs, pretty simple. No concerns on writing those, okay? So I want to thank you for taking good notes today and using your knowledge of transformations and how graphs move across based on their equations. So I look forward to seeing you again. Thank you. Kincaid out.